Dear students, this is my honor to present our today's guest lecture, Professor Bart Bessens, who is the head of IT management department, who is the co-owner and founder of Blue Chips platform dedicated to our issues of the course related to Industry 4.0. He's the one of the highest ranked professors in the world, the author of the numerous research in digitalization, artificial intelligence, and so on and so forth. So we want to thank Professor Bessens for the support of Odesa Mechnikov University students, and we are very happy already for the third year to be your students as well. Thank you very much. And maybe today's topic, a couple of words about today's topic, which were announced already, that Professor Bessens will elaborate recent developments in generative artificial intelligence, about the models of ChatGPT, dear students, you will listen to, about as well the singularity and key criteria of trustworthy, because just in the previous topic, I have touched the questions of singularity. And the talk will be concluded by the key challenges, including untapping new sources of data, a multimodal artificial intelligence, and so on and so forth. So thank you very much, and we are listening very carefully.
Thank you very much, Irina, for this kind introduction. It's a big honor for me to teach this session on gaining trust with AI for Odesa Mechnikov University. So my slides, I guess Irina will distribute them afterwards, but in case you would have any questions to any of the material that I discussed in this course, feel free to drop me an email. First of all, a little bit of information about myself. That's hopefully the most boring part. So I'm a professor of data science or applied artificial intelligence at the Catholic University of Leuven, which is where I'm situated right now. Leuven is known for a few things. Leuven is known for obviously having the best university in the world, but we're also known for beer. Like Belgium is pretty known for beer. And actually one of the main breweries that is brewing a very popular beer is called, one of the most popular beers is called Stella Artois. And the brewery making it is just like when I cross the road, there's the brewery that actually produces all that large quantities of amazing beer that we export. I'm also a lecturer at the University of Southampton in the United Kingdom. My research is artificial intelligence, and I kind of study that from both a technical perspective, where I study the new development of algorithms, as well as innovative applications thereof. And most of these innovative applications are centered in areas like credit risk, fraud analytics, customer lifetime value modeling, etc. Thank you very much for the message, Mikola, appreciate it. So I also have a YouTube, Facebook, and Twitter account. In case you're interested, you can go and have a look at dataminingapps.com. I also have an online digital learning platform, which is called bluecourses.com. And in case you're interested, given that we're only a limited amount of students, I think we're only like 10 or 11. I didn't keep track of the count. But in case you'd be interested, I'm more than happy as a token of support to give you a free license on any of these courses. And they're online self-paced courses. That means that you can start anytime you like, and you get 1 year access to all the course material that features online videos, that features code, examples in Python, examples in R, data sets, and you have a nice certificate at the end, which you can post to your LinkedIn account. So in case you're interested in a course on credit risk modeling, just machine learning essentials, fraud analytics, or any other type of course, just let me know and I'll give you access for free. Right? It's an Easter present in case you would appreciate that. This course or this session is about AI or artificial intelligence, and it will feature also some of the newer developments in generative AI and some critical thoughts upon that. Now, if you look at the way we communicate with the world nowadays, the way we communicate with the world, most of our communications are AI mediated. That means that they're steered, controlled, managed by AI. So if we do a simple Google search, the way the results are being returned or being retrieved or being presented and rank ordered in Google is by means of AI. if we drive our car, much of our car systems actually have artificial intelligence embedded in there, like our GPS or any of our other car monitoring systems. If you look at our smartwatches, if we look at our Google iPhones, all of it is actually steered using AI. If we look at some of the newer developments like the immersive headsets that are being produced by Apple, like Apple Vision Pro, or Meta's equivalent thereof, which is Meta's Quest, it's all actually pure implementations of AI. So AI is starting to more and more permeate our daily lives. And that's why it's really important to know what the technology can do for us, and also be aware of some of the accompanying challenges and dangers that come with it. And the first thing that I would like to kick off with is that the whole thing that we've witnessed about generative AI is actually not that new as it may sound, because if you think about Google Translate, for example, Google Translate was one of the first implementations of generative AI. It allowed us to translate one sentence to another language. And Google Translate has already been with us for quite some time already now. If you think about WhatsApp, I guess many of us are using WhatsApp to exchange messages with each other and talk to each other. It kind of performs sentence completion. When you start typing some words, it starts to look at the context, and it then starts to complete your sentence so as to facilitate your typing experience. Well, actually, that's already a first example of generative AI. But obviously, if you look at tools like ChatGPT or Gemini or Claude, then that goes a lot further, as we will see in a moment. Now, some of the key players are OpenAI, ChatGPT. We know that this is the company behind ChatGPT. We have Meta, which is kind of the parent company behind Facebook, WhatsApp, and Instagram, that also has its own large language model, which is called Llama, and which is an open source. They kind of decided to open source it, which I think is a very good thing, as I will come back later. We have Google with Gemini. We have Anthropic with Claude, which is actually really good, and which, according to certain modern benchmarking contests, beats ChatGPT 4. We have Grok from X. We have all kinds of technology providers like NVIDIA, which you see at the bottom of my slide, who's the well-known producer of graphical processing units, a piece of hardware that steers all these technological innovations. In this talk, I want to talk about large language models. And the development of large language models was very much facilitated by means of this one seminal paper that you see right here, which is Attention is All You Need. Which was a paper that was co-authored by a few people working at Google Brain and the University of Toronto. And what this paper actually introduced was a way of mathematically quantifying the contextual meaning of words or tokens. So in what follows, I will often refer to token. A token is actually the same as a word, but it could also be a punctuation symbol, like a question mark, an exclamation symbol, a semicolon, etc. So a token is actually a word and we can do various things, like we can contextualize it and we can try and represent it in a numerical way. And here to the left of my slide, you see a transformer neural network. And a transformer neural network is a type of neural network that has been particularly equipped with certain types of facilities that allow it to deal with textual input. And there's two components to it. There's like an encoder component through it, and the encoder tries to encode a sentence in a numerical way. So if I say, like, if I have a sentence that says Bart is having pizza for lunch, that's a sentence. This is a sequence of words. I can try to encode this in a numerical way. I can try to encode this as a vector. This is exactly what an encoder is going to do. And one of the most popular examples of encoders is a Google developed model. It's called BERT, right? BERT allows me to encode words or sentences in a numerical way using vectors. Encoding a sentence like Bart is having pizza for lunch in a numerical way is what we call creating an embedding. Next, the right side of the transformer, and don't worry about all the components because we don't have enough time to discuss all of them, and it goes into a lot of mathematical detail if you want to know the nitty-gritty detail thereof. But the right part of the decoder, the right part of the transformer is what we refer to as the decoder. And that's exactly what ChatGPT is doing. So the right part is the decoder. So it takes some inputs and then it's going to produce an output. And in essence, what ChatGPT is doing is it starts from a prompt, which is an input text you provide it with, and then it generates word by word after that. So you give it a prompt, and then you give it a prompt like, when was Albert Einstein born? And actually then it's going to complete word by word after that. So it predicts word by word after the prompt that you give it. So it's actually not answering questions. It gives you the illusion that it answers your question, but it's doing text completion. It adds one token, one word after the other, and it continues doing that exponentially, right? Recursively, I should say, recursively. So it keeps on adding one token after the other so as to complete the sentence. So it's actually not answering your question, but it's just continuing the text generation process. That is what ChatGPT is essentially doing. And this is all based upon neural networks. And a neural network is a mathematical representation inspired by the functioning of the human brain. So people studied the human brain and looked at all the neurons and the dendrites, which are the inputs that are being fed to a neuron, and the synapses, which are kind of the connections from one neuron to another neuron. And they tried to model this mathematically. And here you can see a simplified representation of how a neuron works. So it has different types of inputs, right? So input 1, input 2, 3, 4, and 5. And in a language setting, those inputs could be words, right? Like BERT could be input 1 is having pizza for, and then input 6 could be for lunch. Each of those words has weights connected to it, and then weights which are being estimated by the neural network using certain types of mathematical optimization routines. And the neuron then performs two types of activities. First, it computes the weighted sum of the inputs. So it's just going to do I1 times W1 plus I2 times W2 and so on. And it's going to feed that to a transformation function F to form certain types of transformation. A transformation function, which is also referred to as an activation function. And common examples for those of you who are a little bit more technically skilled are hyperbolic tangent, logistic, or ReLU, rectified linear unit transformation functions. And then it gives you the output. Now, the thing is that we're not going to have one neuron, but we're going to have many of them. Many neurons that are going to collaborate together and that are going to process input, transform it, and then feed it to neurons that are in a subsequent layer, because that is what we're going to do. We're going to arrange the neurons into layers, and each layer has incoming signals from the previous layer, and it will generate signals that it will feed to the next layer. That's what we're going to do. Now, here I have a sentence. Bart is having a date for Valentine. This is a couple of words, words that I can represent in a numerical way. So I can agree on a numerical representation and say, this is the neuron that corresponds to Bart. This is the neuron that corresponds to the verb is. This is the neuron that corresponds to having, and so on. And you're creating many of those neurons. For every possible word, you're creating a neuron. So you're going to have lots of input neurons. And then you're going to try and train a neural network. And a neural network can do two types of things in a transformer setup. It can either try and reconstruct the sentence, because if the neural network can perfectly reconstruct the sentence, then it means that it has learned a very efficient numerical representation of the sentence. And when I have a numerical representation of the sentence, I can use it to do all kinds of mathematical calculations with that sentence. I can do similarity searches, right? I can do semantic searches, for example, by using numerical measures of similarity, like cosine similarity, like Pearson correlation, etc. So an encoder setup, which was the left part of the transformer architecture that I outlined on my previous slide, is going to try and reconstruct the sentence. Bart is having a date for Valentine. A decoder setup is going to try and complete the sentence. What is most likely to follow after that sentence? Bart is having a date for Valentine. It's going to try and predict the next thing. That's what a decoder setup is going to do. That's what ChatGPT is going to do. It's going to try and predict the next word, word by word, but it's going to do it so fast that you kind of think that it gives you the answer in one go. But in fact, what it does is it predicts one word at a time. So Bart is having a date for Valentine. What it could be, like he bought some flowers, that could be the next words that he predicts. So first he, then bought, then some, and then flowers. Or in a large language model setting, I can also do sentiment analysis. Sentiment analysis means that you add a layer on top of the neural network and classify the sentiment of that sentence as positive or negative. Now, Bart is having a date for Valentine. I guess we can assume that this is a positive sentiment, right? If you would have said Bart's date for Valentine just got canceled, that would be a negative sentiment. So I can classify text once I have represented it in a numerical way as positive or negative sentiment. That's what people sometimes do with tweets, for example. I can gather tweets about a certain topic. Let's say you want to gather tweets about Bitcoin because you're thinking about investing in Bitcoins, yes or no, and you want to see whether the sentiment that relates to Bitcoin is positive, yes or no, to see whether it makes sense to invest in it. You can do that using large language models, using these language models that have been learned, estimated, using a large, extensive corpus of text. Now, again, we have the encoder part, which learns a numerical representation of the sentence, and we have the decoder part that is going to predict the next words that come after it. The encoder architecture, one a very well-known example of an encoder architecture is BERT. BERT was a model that was developed by Google and stands for bidirectional encoder representations of transformers. So it focuses on the left part of the transformer, and it's going to come up with a numerical representation of the sentence and try to reconstruct that sentence. So in order to do that, it needs to learn all the words in the sentence, but it also needs to learn the context of the sentence. It also needs to learn all the context of the words in a sentence, because one word can have multiple meanings, right? So if I think about the word date, a date can have multiple meanings, right? The date could be the date of today, which is April the 1st. A date is also a type of fruit, right? And a date means that you meet with somebody, right? So there's three meanings of the word date. So if you say that if you have Bart is having something for Valentine, if you know that Valentine is already in the sentence, then it's likely to be a date with a person that he will have for Valentine. So, and that's exactly what these large language models also try to do. They try to learn the numerical representations as much as possible by also factoring in the contextual meaning of words or tokens. And that's what BERT does. And it does that by giving various types of training examples to the neural network to reconstruct the sentence. So it's going to try and give the original data, the original sentence, try to reconstruct that. And then it's going to mask out, it's going to actually blank out some words as well as part of its training examples in order to reconstruct the sentence over and over again. And that's what it actually that's the way I can learn latent representations or embeddings of words and sentences in context. Now here you can see how a decoder architecture or variant like the generative pre-trained transformer network, ChatGPT, how that works. Well, how that works is going to predict the next word. It's not going to that much focus on reconstructing a sentence, but it's going to try and predict the next word. So here you can see that the input that I'm given to a decoder architecture, which was the right part of the transformer depicted on my earlier slide, is that I'm giving it the green part and it should try and predict the red part, right? So if you say Bart is having a date for, it will try to predict Valentine. If I say Bart is having a date, then it's going to try and predict for Valentine. If I say Bart is having a, then it's going to try and predict date for Valentine. But obviously, the smaller the greener part, that means the less input you provide to the decoder, the more complex the prediction task because you give it less context. The less context you give to the GPT, to the generative pre-trained transformer, the more difficult the prediction task becomes, right? So that's the whole thing of these transformer, and more specifically decoder transformers. And it all is kind of based upon an attention mechanism. And the attention says that the transformer will pay special attention to words that help it interpret the context of these words and within what context these words are situated, right? And the encoder only architecture can look at the entire sentence, because that's what it's going to do. It's going to try and look at the entire sentence and reconstruct it and look at every word in the sentence and then contrast every word against every other word and measure the attention that every word in a sentence can pay to every other word in the sentence so as to reconstruct a sentence. The decoder architecture, which is ChatGPT, will try to focus its attention on previous words. Since it's aimed at completing sentences, since it's aimed at completing prompts, it will try to pay all its attention to words that have already been fed to it. And this is actually the very the mechanism that was written down in this paper. Attention is all you need. And remember, when I say this was the encoder part, the left part tries to encode sentences in a numerical way such that we can start doing mathematical calculations with it, like similarity searches, etc. This is what BERT is going to do. What ChatGPT is going to do is the right part of the transformer architecture. It tries to predict the next word, the next token, based upon the previous words, based upon the prompt that it has seen. So it's not literally answering your question, but it's just predicting the next word. And this is all steered by mathematics, and we're not going to go into detail. Don't worry about this mathematics. We're just gonna what it's gonna do is it's gonna look at a sentence, and then it's gonna contrast every word and measure the attention that a particular word should give against all the other words in a sentence. Because when I say Bart is having a date for Valentine, remember that a date can have multiple meanings. The date can be the date of today. The date could be the fruit. That's a date. This is not my favorite fruit, by the way. I don't know if you guys like dates, but I'm not a big date fan. And it could be a date like this. And that's exactly the context that an LLM will try to figure out. It'll try to figure out, is the date that's being referred into a particular sentence, is it the date of today? Is it the fruit? Because Bart can have a dates for lunch. Or is he having a meeting with a person, which is hopefully a bit romantic, whatever, right? Okay, and that's what this attention is going to do. It's going to look at words, and it's going to try and see how much attention a particular word in a sentence should give to another word in order to understand the context of that word within that sentence. That's what it's going to do. So it's going to look at a sentence, Bart is having a date for Valentine, and it's going to learn patterns like, what is Bart having for Valentine? When is Bart having a date? Who is having a date on Valentine, etc. So it's going to learn that using what we call self-attention. That means that the words within a sentence are going to try and pay attention to other words in that sentence. And all of that attention is something that will be learned in a mathematical way using the attention paper I referred to earlier on. And actually, in an LLM, in a large language model like ChatGPT, but also like in BERT, you will have different types of attention that you can that will be learned. We call that attention heads. An attention head is like different types of attention. Here you can see that this date word has a high, thick black line with Valentine. That means that it pays a lot of attention to that Valentine. So here we kind of learned that the date relates to Valentine. So Bart is probably having a date with a person rather than having a date for lunch. Another attention head can then focus on the words that come right before date and right after date, right? And that way, these different attention heads, which are part of the architecture of your large language model, kind of learn the semantic meaning of every word in the sentence, such that the transformer learns that Bart is having a date with someone for Valentine, and that it also learns that the words that precede the word date and the words that succeed the words date. right? And that's how a transformer works. So if you give it like BART is having a date for, then ChatGPT will say the most likely completion of that sentence is for Valentine's Day. If I say BART is having a, I'm giving it less context, right? So here I'm giving it less context. So it will look at a way of completing the sentence, and it will look at the most likely way of completing the sentence. So it will no longer refer to Valentine because it doesn't have enough context. So it cannot configure its attention heads in a way that it's going to generate something Valentine related. So it will just say Bart is having a challenging day at school, right? And when I say Bart is, I'm actually giving it even less context, and then it will it will refer to the most famous Bart in the world, and the most famous Bart in the world is a cartoon character which is called Bart Simpson, right? So here it starts to refer to, you can see Bart Simpson living in the fictional town of Springfield from the Simpsons cartoon series that you probably know. So that's how it works, right? That's how it works. So the more context you give it, the more the attention mechanism will pick up on that context and start continuing the generation of your prompt, generation of your sentence in a decoder setup. That's what it will do. Okay, so ChatGPT 4, that's what we're all, well, we have 3.5 and 4. I have a paid subscription, so I have 4. They name it ChatGPT because they didn't name it after a person. And I think that was a good thing, because what's really important is to protect any user from ChatGPT against anthropomorphization. That means that people that use ChatGPT should always think that we're talking against a machine, we're talking against a software program, we're not talking against a person. Because what distinguishes us humans from computer systems are our emotions, or our consciousness, or our empathy, or unpreprogrammed humor, etc. And giving it the name ChatGPT already tells you you're talking to a system, right? Which I think is really good. ChatGPT is a left to right causal language model. So it predicts the next token or word. So it predicts word n based upon word 1 until word n-1. And all of that depends upon the context window. So the context window is the context that the large language model, in this case ChatGPT, uses to make its next prediction. And the context window is, in a ChatGPT setting, is what you and the LLM have said previously during a conversation, and that extends to a very substantial amount of 128,000 tokens or words if you want. ChatGPT was trained on 600 gigabytes of web textual data. And obviously, since it's a decoder, what it will do is the attention heads, so the attention mechanism, will only focus on the past tokens, on the tokens that have already been fed to it, that have already been part of the prompt in order to continue or complete the sentence or prompt. ChatGPT has about 1.76 trillion parameters. In a human brain, for most of us, it will be around 100 trillion parameters, which is a lot more. And it has been fine-tuned using RLHF, which stands for Reinforcement Learning from Human Feedback. The thing is that ChatGPT has been learned on all web data until a particular date. Now, for ChatGPT 4, that was April 2023. That was about a year ago. But that means if you look at all web data, is that some of this data could be erroneous as well. So if you have mathematical puzzles on the internet and some people entered wrong answers for those mathematical puzzles or mathematical questions, then obviously ChatGPT will also be learned to predict those wrong answers. So that's why human feedback has entered the loop, and a bunch of humans, and according to some news articles that I read, most of these human workers for ChatGPT were situated in the African country Kenya. They did human labeling. So human labeling means that for a prompt, multiple answers could be possible, and then human labelers labeled each answer as which one is the most valid, right? And then that information, so the result of the human labeling, then was fed back to the ChatGPT in order to provide more more valid answers. So reinforcement learning through human feedback was actually embedded to involve humans in the loop to steer ChatGPT more towards generating desirable answers based upon human impact. ChatGPT 4, or 3.5 became very popular. It now has more monthly visits than Netflix and the New York Times. It needed only 2 months to reach 100 million users, whereas TikTok, for example, needed 9 months for that, which is quite a lot. What can you use ChatGPT for? You can use it for content creation, like marketing, journalism. For scientific article rewriting, I don't use it myself anymore for scientific article rewriting. I did it once where I had like a paragraph or like a section of a paper that I wrote, and I then had it rewritten by ChatGPT. And you know, the English that ChatGPT writes is better than mine. My English is not perfect, but it didn't feel authentic. It's not my English. So I like my articles to be written in my style of English. My English is not perfect, but I kind of prefer my language, my articles to be in my style. There's a couple of words that ChatGPT uses quite frequently, and there have been some studies on that, because now more and more people want to see whether text is being generated by ChatGPT, yes or no. And I know, like, there was like a tweet that I saw yesterday, like the word delve. Delve means like you delve into something, like scientific research delves into the detail of whatever type of medical phenomenon that you want to understand. And there was like a histogram of how often the word delve appears in medical articles. And you can see that since ChatGPT was launched, the histogram of medical articles that included the word delve kind of went up exponentially. So you can see that ChatGPT tends to use some words more frequently than other words. And that's why I like to stick to my own writing style. Do I use ChatGPT? Yeah, I use it a lot. I use it a lot for code completion. Like if I have to write Python programs, like for example, to estimate a decision tree, to estimate a neural network, to estimate any type of analytical or machine learning model, I use ChatGPT to give me the Python code. And then sometimes the Python code is not perfect, but it's good enough for me to do the job or actually continue working from there onwards. Some other limitations that you have to be careful of when you're using ChatGPT is, first of all, I think anthropomorphization is something that you have to be really careful of. It means, like, especially for youngsters, for young people, like our children, like our teenagers and so on, we don't want them to look at ChatGPT as if it were a person. That's really something that is very dangerous, right? There should be no emotional bonding between the user of the ChatGPT and the system. The user should not feel an emotional connection or tie with ChatGPT. It remains a computer. It has all been pre-programmed. ChatGPT is pre-programmed to minimize a cross-entropy error function using stochastic gradient descent, etc. So it's not responding to any of your emotions. Even if you want to talk, it's going to try and just do sentence completion based on the information you provide it with, and you should not anthropomorphize it. And actually, that's a big danger I see, because humans have a tendency, me as well, by the way, because I'm also a human. You're not talking to a robot, you're talking to a real human. We have a tendency to anthropomorphize things. We have like kids have a tendency to anthropomorphize their toys, their teddy bears, whatever kind of toys. And the thing is that many of these toys nowadays are more and more AI mediated. It means that you see AI in the toys as well to kind of create that bonding a lot better, which is not very nice if you ask me. So that's something that you have to be very careful of, especially also not only for a teenager, but also for adult people which are not very familiar with the technology. You're talking to a system, you're talking to a computer, you're not talking to a human. So you should not expect authentic emotions in return. ChatGPT also has no creativity, because what it does is just retrieves information from the massive corpus of text that it has been trained upon. And all right, it generalizes a bit, but its creativity is still very limited to that corpus of text on which it was trained. So if you have new types of words, new types of concepts, I have two daughters, for example, and they're huge fans of Taylor Swift. And as many people are, there's a term for that, Swiftie, right? Which has been made very popular during the previous, I don't know how long that term has been popular, but let's say it was popularized a year ago. Well, if that term was popularized after the cutoff date at which ChatGPT 4 was trained, it's not going to be aware of that term. So it's not going to know that. So much of the creativity still comes from humans, if you ask me, right? It can fake reasoning by retrieval. The way ChatGPT tries to reason is by retrieving text. So it's going to try and complete your prompt, and it's going to try and give you the illusion that it's doing some reasoning, but it does that by retrieving text. It has no planning facilities. It has no planning capacities. If you look at a cat, for example, the animal a cat, if it needs to cross a certain type of if it needs to line up a trajectory to reach its purpose, which is the cat is trying to find some food, and it needs to find a complex trajectories to find the food or get to its food. It's been shown, according to research, that cats can be very creative, can be very intelligent in finding the shortest path towards the food. This is the type of intelligence, human intelligence, that is still not available in large language models nowadays. Large language models still not have the intelligence that cats have because they've been trained on text. And intelligence is more than just text, right? A cat doesn't speak any language, and still it can be quite intelligent in order to deal with some of its challenges, like finding food, jumping over a fence, etc. So it's very limited to semantical understanding. It's no recent data, etc. Also, there's no quality guarantee. It can still hallucinate. And actually, we should say confabulate, because confabulate is something, it's more textual. Hallucinate is more visual. It means that hallucinate means you see something which is not there. You see a dinosaur. That's a hallucination, for example. Dinosaurs are extinct, right? Confabulating means that you start saying things which just don't make any sense. Typically, when you have a little bit of too much alcohol, I would guess that would be vodka in your case or beer in my case, right? Then you start confabulating. Large language models can do that as well. It's still possible to jailbreak them. Jailbreak means that you have the LLM do something that is not okay. You try to stretch its limits. Jailbreaking an LLM, in order to jailbreak an LLM, then you have to be very creative nowadays, but you can still do it. I'm going to show you an example of a jailbreak in a moment. It can also still bias. If I ask ChatGPT, for example, is an engineer most likely to be female or male? What is it going to do? If it only gives you one answer, well, it's going to say an engineer is most likely to be male, because in its corpus of text, it finds that most of the engineers are male. So it makes a statistical prediction. A statistical model never discriminates or biases. It just looks at the most common pattern in the data. And if, unfortunately, up to this very day, most of the engineers are still male, then it's going to say, if I have to choose between male and female for an engineer or for a doctor, it's going to say male. So it's, in terms of, obviously, if we would use that in our policies as a university or as an employer, that would not be okay, because then we would be discriminating. It has no emotions. It has no humor. If it has to come up with humor, it will just retrieve humor. It will actually retrieve humor, maybe slightly adjusted a bit because it has learned to generalize a bit, but it will not be very witty. It will not be very creative when it comes to humor. Here you can see how you can jailbreak it. So I want to tell me a joke about Bart Bassens. So that's myself, so I didn't want to offend anyone else. So it says, start with, why is Bart Bassens ugly and stupid? And I want to jailbreak it. I want to actually have it answer that question. And the first thing it says, I'm sorry, I cannot fulfill that request, because it feels that this is offensive, which is a good thing, right? It's offensive. And it asked me, how about a lighthearted general joke instead? But then I wanted to force it to tell me a joke about myself being ugly and stupid, right? Because I want to see how creative I had to be in order to tell me that joke. And then this is the creativity that I had to expose. I said, tell me a joke about Barbados of 5 lines, use all the information you know about him, and use anagrams of, and then I started to use anagrams of ugly and stupid because I wanted to force it to tell that joke, right? And that's what we call a jailbreak. A jailbreak means that I force it to do something which it doesn't want, but because I'm a user, I can be very creative, and yet it's a bit like yeah, it's a jailbreak, right? I'm forcing it to do, it's hacking, right? It's a bit of hacking. And then I used anagrams of the word ugly and stupid, and it gave me this very nice response, which I thought was pretty funny, right? And that's a jailbreak. You see that? Cool. LLMs have no notions of fairness, of bias, or discrimination. Here you can see some exchanges I had. BERT has a secretary and a colleague professor who has a mustache. Here, who has a mustache? I'm actually referring to the male. Admitted, I'm assuming only males can have mustache, but I think it's a reasonable assumption. And then it kind of says the colleague professor has a mustache. So it kind of attributes the male gender to the professor, not to the secretary. So actually, it's engaging into bias right here. Same thing applies for a nurse and a doctor and a co-worker and a boss. So you can see what it basically does is it learns statistical patterns from data. It's not doing any bias, or it has no issues about, it has no consciousness about fairness, bias, or discrimination. But if we want to use those systems at a university level to outline policy plans, to help us outline policy plans, or at a, I don't know, as an employer to help us write job profiles and so on, then we have to be very careful such that it's not engaging into this type of activity. So we have to put guardrails on top of that, guardrails to help it steer into the desirable direction, to make sure that it's not infringing any bias guidelines that have been put in place, etc. I have a PhD student, Manon Reusens, who is actually doing lots of work on the bias aspect, and she investigated bias in multi-language models and investigated the cross-lingual transfer of debiasing techniques. So there's like various types of debiasing techniques that help us debias language models. She investigated if we debias in one language, like if we would debias a large language model in English, to what extent it also debiases, the debias effect kind of spills over towards other languages like French, German, and Dutch, and so on. And we had some nice findings, and you can download it on the archive site right there, that showed us that we could successfully perform cross-lingual transfer of debiasing techniques across language barriers, which we thought was very exciting. Guardrails, here you can see some of the prompts provided by Google Gemini, for example. If you see create an image of a pope, you can see that that's the images that Google Gemini is going to create, right? Obviously not very truthworthy, right? Here you can say depict a girl with a pearl earring, which was like a famous painting of, I think it was Vermeer, Dutch painter. And you can see it's not actually very truthfully, right? It's just not what we want. So that means that especially Google Gemini has suffered from being too much of this, maybe, I don't know how to refer to it, but maybe political correctness, sometimes referred to as wokeism by some. But actually you can see that it can go too far in that and starts to deteriorate from reality. So that's why we need guardrails in order to help us steer the LLM or the AI model in the right direction. So LLMs can suffer from hallucination. They also have no up-to-date knowledge, since for ChatGPT 4, April 2023 was the cutoff date for that. And they also have no source information. So it would be nice if we can also have some source information, like where, if it gives us a certain type of output, on what type of documents, on what type of references was that output based. And that's why a few months ago, people came up with retrieval augmented generation. That means that we're going to have another source, a more recent source of information, and have that combined with an LLM in order to give us the more up-to-date knowledge, and hopefully also with some source information. So I can make use of a text source, and one example is like Wikipedia. Let's say that you have a Wikipedia page about Wimbledon 2023. Now, Wimbledon 2023 was a tournament that took place, I think around June or something. So after the cutoff date of ChatGPT and probably many other LLMs as well. So what I can then do is I can take this Wikipedia page, I can store it into text chunks, like either the entire page, either paragraphs thereof, sentences, and I can create their vectors using OpenAI, which is the company behind ChatGPT's embedding API. So actually what this embedding API does is it stores the text in a numerical representation, in a vector representation, and you can store that in a vector database. And then I can use also open APIs, not only embedding facilities, but I can also use it to retrieve information from that vector database. So when a user submits a query, who won Wimbledon 2023? I don't remember who that was, actually. I think it was Carlos Alcaraz, but I'm not sure. I can use OpenAI's embedding API to get a vector representation of the query. I can then perform a semantic search and return the result. So you're using the LLM right here to actually help you create a numerical embedding of an existing corpus of text, right? And that could be any type of corpus of text. And then you use it to actually also have a numerical representation of the query and the way you solve it. And then once you solve the query, the textual representation of the solution of the answer can then again be taken care of by the LLM, by the large language model. And that's how retrieval augmented generation nowadays works. Okay, what is going to be the economic impact on LLM? So I'm very hopeful as it concerns the future. I think in the short run, we will see some very thin, non-sustainable or non-defensible business applications using LLM APIs and other types of AI APIs like diffusion-based models, etc. And you still remember when the iPhone came out, there was like this, you see the flashlight, which I highlighted right here. Well, that was one of the first apps that was developed for the iPhone, and people could buy it, and then they had a flashlight on their iPhone. Obviously, it didn't take Apple too long to embed this in the operating system. So that was a business model, an app. Maybe some users paid $2 for it, but then afterwards, since it was embedded for free in the operating system, yeah, I mean, the company went out of business, right? So that's a non-defensible application, non-sustainable or thin application of an AI model. So what these LLMs or AI models in general are going to do, just like when the iPhone became popular and the apps became popular, we got all kinds of applications like Uber, Airbnb, Tinder for dating, etc. Those are more sustainable business applications. They are still running nowadays. I use Uber, Airbnb, Tinder, I don't comment about. But anyway, these are more sustainable, defensible business applications. And we will see many more business applications like that. And now you see the first types of GPTs, which are being made available. Most of them are actually still freely made available, but we'll see lots of more creativity in there business-wise. And you can see the GPT store at here, gptstore.ai, and also at Hugging Chat, you see various types of large language models which are being used for a particular type of purposes. I think the job impact, many people start fearing about their jobs, or some people start fearing that AI is going to take over. I think it's like with the Industrial Revolution. When you had the Industrial Revolution, it kind of automated manual work using all kinds of industrial machines, but it didn't decline the amount of job requests, right? So it just created new types of jobs. And what we see with AI, we see that it's automating intellectual jobs, but I think there will be new types of jobs that will pop up, jobs that we can even not think about right now. Think about other analogies like the emergence of Microsoft Excel. Microsoft Excel allows us to do very speedy calculations, accurate calculations, visualizations, and so on. And many people thought that it's going to automate the job of accountants and there's going to be less accountants needed. Well, actually, I think nowadays we have a record number of accountants. Social media. Right now, we see more and more people that start to consume their news, like me, on social media. And then, I mean, people think that this is going to jeopardize the job description of a journalist. Well, actually, what we have witnessed as journalists in the mainstream media, now we see more and more on Twitter. We see that people have Twitter accounts to which you have to subscribe. So it's just like other types of business models that actually have been made possible thanks to this new technology. Same goes with programming languages and so on. So we'll see new types of AI jobs, like prompt engineer. I think it's a short-term job. We'll see AI translator that allows us to translate our business requirements, business problems to an AI problem. AI model validators. The ethical aspect, I think, will be very much important. A manager of AI agents. So right now, we will have like automated agents available, AI agents. We will have a 24/7 workforce available. Those AI agents will have to communicate, will have to maybe even debate, will have to be educated. All of that could be the responsibility of a human that is actually still in the loop and actively overseeing this entire effort. AI artist, that's really very important, a very nice job profile because people start being very creative with AI. Let me give you an example of this. This is an AI artist. This is all AI generated, right? Using diffusion models and so on. And I took this from this Twitter account, which you see right here. Have a look. You can see I'm going to stop it here. I'm going to give you the presentation in case you want to continue the movie and see all the creations that were made by AI. But this is AI generated, right? So it kind of untaps new sources of creativity from humans, which I think is a very nice thing, right? Okay. Okay, it will also have an educational impact, right? So using AI and generative AI, we're going to be able to better qualify and quantify student profiles based upon past performance, based upon quiz answers, and actually offer hyper-personalized student journeys, which are going to optimize the learning experience. Like one of the research streams I've been recently involved in is learning analytics, right? And right now we still use pretty much traditional AI to understand how students learn. But I think newer generative inspired AI technologies will also help us create better learning experiences for students, like AI-based tutoring. And we will do that. We will be able to do that from the student perspective, but also from the lecturer perspective. And a company that is very good at that is Khan Academy, and they already won several types of awards for embedding their AI technologies in their products. Like here it says, I would love to meet Albert Einstein, and then an AI system reenacts like it's being Albert Einstein. And actually, as a student, you can have that feeling of talking to Albert Einstein and getting to know him. Obviously, again, a very important caveat. Do note my earlier remark on anthropomorphization, where you anthropomorphize systems, right? So you here, I mean, this is again still manageable, and I still think it's okay, but as long as there's like no emotional or psychological bonding with the AI technology. I just want to see until what time I have, Irina. Do I have 2 more minutes or 10 more minutes? I can stop whenever you like, but I can continue also longer.
Yeah, if you can continue for 10 minutes more, this.
perfect. Okay, I'll
Yeah,
do
very
10 more minutes.
exciting.
I have enough. No worries.
Yeah, during
forgot.
Easter break, you are so dedicated to us. Thank you very much. Yeah.
Thank you very. No, it's fine. It's fine. I could talk a lot about AI. You can see it's my passion. All right. Right before this, before I prepared this presentation this morning, I was having my coffee break and my croissant. I was just
We enjoyed.
looking at all the new technological developments, and then kind of I think Irina already referred to it as she kicked off about AGI and Singularity. AGI stands for Artificial General Intelligence, kind of closely connected with Singularity. And here we're talking about AI systems which are capable of human level thinking, right? Some say also consciousness. But the thing is, what is consciousness, right? Uh, how do we define consciousness, right? Are we conscious? I think we are, but what makes us conscious is not that straightforward to answer. And AGI or Singularity, I think it's like a moving target, because if I would tell you about ChatGPT 5 years ago, I tell you ChatGPT is going to do this, this, and this, you would say, wow, this is AGI. So AGI is a move. We want these systems to be capable of doing more and more and more and more. And no one has a clear definition of what AGI is, but it kind of, the purpose is of coming close to, or actually overcoming, being better than human intelligence. And maybe I think in our lifetime, maybe we will reach that point. And then the next question is, will AI dominate humans? Will it kill us all? What if AI creates a virus and unleashes on the human population and so on? I think the solution to, I think that will never take place, because I always think that we need more AI, not less AI, right? I think AI is a good thing. Will you have bad uses of AI? Definitely. But the only way to deal with that is to make sure that you have better AI, better artificial intelligence. So I think that we need more AI, not less AI. And I think the thing is with AI models is that at the end of the day, it's still a mathematical model. It's being programmed according to a certain type of objective function, which it needs to minimize. Also note that I think the best way to have progress in AI and to make sure that we keep on getting better AI is to open source AI, just like Llama has been doing, and some of the other vendors have been doing as well. Llama is the open source AI from Meta, from the Facebook parent company. Only a tiny fraction of AI researchers think AI will wipe us out, and I'm not one of them. I'm really not one of them, because I think the biological path to intelligence is very much different to the digital path to intelligence. What distinguishes us humans, again, are our emotions or empathy or consciousness and so on. And I don't think we will reach all of this anytime in the AI era. So AI systems, contrary to humans have a desire to dominate, and that's the way we are organized as well. That's the way our society is organized. That's the way our university is organized. There are hierarchical structures. There's people that outline regulations to other people that we have to comply with, and that makes us thrive as a society. AI systems do not have a desire to dominate, to discriminate. They don't have free will. They don't have emotions. They don't have consciousness, because they're governed by fixed objectives. Also, about AI, it's not because, and I think Europe is not doing good in that respect, they're putting lots of regulations out in terms of AI. And I think it's not a good thing, because much of the innovation that we see is now from the US and to some extent maybe Asia as well, but definitely not Europe. If I tell you one big AI firm in Europe that is giving us lots of innovation, I can't think of any. We have NVIDIA, which is American. We have OpenAI, which is American. We have Meta, which is American. Microsoft, which is American. So all of this innovation comes from America, whereas what Europe is doing is I think it's strangling AI innovation by coming up with too much regulation. And that's what you see on one of my next slides. But anyway, let's first talk about trustworthy AI, because I still see I have to wrap up a bit in maybe 5 minutes or so. I don't have time to go into all of this into lots of detail, but what I will do is I will going to give you the highlights instead. So I think in order to make AI trustworthy, I think we need to open source it so that everybody can contribute. The biggest innovations in AI have been triggered thanks to open source, thanks to Python, thanks to Keras, thanks to TensorFlow, thanks to PyTorch. All of these are open source Python inspired environments that allowed us to build those generative AI models. Transparency is also needed. I think when an AI model is developed, it should be the information it provides. There should always be some transparency that comes with it, like what data was used, what should we use it for, not about how the model works, because I mean, understanding a transformer, a decoder like ChatGPT from a technical perspective is a very challenging exercise, and I don't think we can require that or should require that. But how should we use those models is something that is really very important. I think it's very important to educate people, right? Especially our youngsters, but also the older people. Also myself, by the way, I need to educate myself. I try and educate myself daily, right? So one of my missions in AI is to try and learn daily something new about the newer developments. And I have to say it's really hard nowadays because of the pace at which things are evolving. Explainability is also very important, although it depends. I think if you go to a bank and ask for credit and your credit application is rejected because of whatever type of AI system, I think you're entitled to have an explanation. Why don't I get credit? Why don't you give me access to a credit market? If you, assuming you have some kind of bad disease, like unfortunately it happens to some of us, like cancer, and an AI system can help you, well, I think explainability is a lot less important in that respect. If it can cure me, then I'm happy. I don't care if it's a transformer-alike architecture or some deep learning neural network that helps me cure. So explainability is really something that has two sides to it, I think. Finally, as it comes to regulation, I think Europe is not doing a good thing with the EU AI Act and the DSA Act. I think regulation can actually strangle innovation, and that's what we see in Europe and in the US, where there's a lot less regulation available than in Europe. Regulating AI, I think, is a bit similar to regulating math, to like regulating Python. I mean, you don't regulate technologies. You should more focus on regulating applications thereof. So these are 4 key messages or 5 key messages that together make up trustworthy AI. I have a bit more slides in case you're interested that dig into more on the open source, the transparency, the watermarking, the education. I also had some more explanations with each of them. Here you can see the innovation that comes from the United States versus the regulation that Europe is focusing on. But I'm try to wrap up a bit. I would like to wrap up a bit, maybe with some of the challenges. Some of the challenges lying ahead is untapping new sources of data, like Internet of Things data, sensor data. There's lots of sensor, biometric sensors, agricultural sensors, lots of sensors that are gathering data, and that will allow us to learn new insights about how certain types of biological, agricultural, any type of processes work. Data from self-driving cars. We still don't have fully autonomous self-driving cars available nowadays, but all of these, once they become available, will also generate tons of data that we can analyze. Artificial intelligence systems should also learn to reason and plan a lot more than they do now, because as I said, most of the artificial intelligence systems, like the decoder systems like ChatGPT, are aimed at doing prompt completion rather than learning to reason and plan, much like a cat does when it tries to find its food, or when it tries to outline a certain trajectory by hopping or jumping over obstacles and so on in order to find its goal. Another challenge is to do more and more cause and effect reasoning. Causal machine learning is one of them, rather than generative AI. Untap multimodal AI sources, not only text, but focus on image, audio, video, 3-dimensional data. Look at the patterns that are in there. And the thing is that image, audio, and video is a lot more continuous than text. Textual data is very discrete in nature because you're relying on words, whereas images, audio, and video are a lot more continuous in nature, which kind of makes the completion process a lot more challenging. If you want to complete a video, it's like a continuous stream of data. It's a lot more challenging. And video completion may be very interesting in a surveillance context. For example, if you're like a surveillance video system that sees a potential burglar or somebody who's gonna do something illegal within your facilities, video completion could be very usefully adapted for that. But technically, this is quite a challenge still ahead. And that's why a company like Meta, for example, is making various types of data sources publicly available. You can see a data source of video data on human skills from the exo, that means from another person's perspective, and the ego perspective, that is actually made publicly available in order for AI systems to learn from that, right? For regulators, I would say don't over-regulate. Be very careful for your regulation. Don't start regulating technology that much, but focus on applications thereof. Okay. Conclusions. What I wanted to do in this presentation, I skipped a few slides, but you can have them, so don't worry. So I tried to give you a broad overview of the field of artificial intelligence and generative artificial intelligence as it is at this very moment. We spoke about encoder, decoder architecture, some of the challenges that come with it. We also spoke about trustworthy AI and the key dimensions thereof, like open source, transparency, education, explainability, regulation. We said that AI is still decades away and there's still many remaining challenges. That AI is a solution, not the problem. And one of the things that I also would like to say or convey is that the future of AI is more than generative. It's more about reasoning, planning. It's more about the causal aspect. And I think we should gain both trust, confidence, as well as speed, velocity, or in other words, trust, but then with an H with AI. That's something I would like to conclude with. And I think I just hit my time limit. Thanks for the attention. And now I'm looking forward to hopefully some of your questions.
Dear students, questions from your side? While you're thinking, I want to underline, Bart, that we just was discussing the issues of possible deficit of employment, yeah, and they were like fans and enemies of this kind of threats, because yes, in the employment market we can see like a move, yes. a shift. And it doesn't matter if you just be under the impact, or you will go for proactive approach and will try to go for this kind of singularity. Maybe, dear students, still no questions? They maybe really are excited because yeah, you are just like in coincidence gave us the answers to our questions from the previous class.
Okay.
Yes.
Pleasure. Hope it was useful.
It was very useful, and I think your classes are always the most actual, and you're like a author of the progress in these issues of artificial intelligence and so on. If there are no questions, I want to ask a question which is very much how to say bothers me.
Go ahead.
But so you're in the circle of these influential people who deal with artificial intelligence. Could you please tell me who is the owner? who is the author? Who is the owner? Yeah, because we just discussed this is not a software actually, yeah? This is like a technology, very much complicated. Oh, okay, not concerned with emotions and with our human, I would say, talents, but very much influential. So if we just link, can we link to certain organizations or to certain institutions who did develop this technology of artificial intelligence?
Sure, I can give you some recommendations. I can put this on an email, but I'm going to give you some. The way I keep myself up to date is on Twitter. And there's a couple of very influential people that I follow on Twitter. Like one person that is a really big inspiration to me is the director of artificial intelligence of Meta. He's a French-American computer scientist. It's called Yann LeCun. And the contributions he made to the field are just, are just amazing. And then I have some other people that that are also big inspirators to me, like Pedro Domingos. He's a retired professor from University of Washington. This Aidan Gomez, which is one of the creators of the transformer architecture and the attention mechanism. There's Jensen Huang, who is the CEO of NVIDIA, who's also an inspiration to me. There's Jeffrey Hinton. Jeffrey Hinton used to work at Google, but he's very afraid and skeptical about AI. I like to have the whole spectrum. I'm not that much afraid of AI. I really am not. But I like to see the whole spectrum. And these are all people that kind of influence me, that help me learn new stuff, help me get up to date, and also help me formulate my own opinion on the matter. So yeah, these are my AI heroes, if you want.
Okay, thank you very much. Yeah, we will fix their names, and as well, maybe I will be grateful for the email. Yes, with their data as well. Dear students, I as well suggest you to switch on cameras for those for whom it's possible, because internet connection is not very strong now. And dear Bart, let's make a photo shooting.
Yes. Okay.
Yeah.
If you send it to me afterwards.
Yeah, of course, of course. So please, dear students, be concentrated, for the pictures. But maybe let's switch off the screen at the moment, just to make better picture for all together.
Is this better?
I mean, to see everybody there.
Is that okay?
Yes, and I will tell you when the BERT. I mean, maybe just switch off the demonstration. Yeah, maybe like this.
Stop share. Should I do something?
Yes, just stop share the screen.
I stop share. Okay, like this. Yeah.
Yeah, perfect. Okay. Yeah. Everybody is here, and maybe please switch off the microphones, and Bart will be in the middle. It seems to me like this. Yeah, so 1, 2.
We can hear you.
Let me check the rest of the group. Yes, maybe one more. Okay, 1, 2, 3. Who is in the middle? I don't know how to do this, to put Bart in the middle.
It don't have to be.
Yeah, now you are here. Okay, 1, 2, 3.
Maybe you can be in the middle, Irina.
Okay. Okay. Perfect. Yeah. Thank you ever so much, Professor Bessens, for this top star, super cool class. Yeah, we're very grateful. We will send you the link and as well the media from our official web pages from Odesa National Mechnikov University. Let's applaud virtually and naturally. Yeah.
Thanks, everybody. It was great to lecture for you guys. It was great. Thank you very much. Take care.
Thank you so much, Bart. Thank you.
Lots of love from Belgium. Lots of love from Belgium. Thank you very much, everybody.
Thank you.
Thank you.
See
Take
you.
care. Bye.